I know you've probably seen cross products before, but I just want to highlight some terms that you might not have heard before and that you might see in the future, and that is the terms means and extremes. So we've set up our proportions using fractions, but if you set them up using our other method using colons, right? 2 to 3 is equal to 4 to 6. The outer numbers are called the extremes, and the inner numbers are called the means. And we know through reviewing cross product that the product of the extremes is equal to the product of the means. So if you see means and extremes somewhere on a standardized test or in your homework, you know what that means. It means that if you set up proportions using the colon method, extremes are the outer, means are the inner. Now I just want to review some different ways of setting up proportions and how it can help us solve different types of problems. So first we have A over B is equals C over D, right? That's equivalent to saying that B over A is equal to D over C. So basically we just did the reciprocal of each of these comparisons. So let's just see how that looks. If we have 2 to 3 equal to 4 to 6, we can just find the reciprocal of each of these and set them up as 3 halves equal to 6 over 4. Right? It doesn't change the relationships. In fact, we can even see the cross products remain the same, right? Here we have 3 times 4 is equal to 6 times 2. Here also we have 3 times 4 is equal to 6 times 2. Another way we can explore proportions is to say A over B equals C over D, and that is equivalent to A over C equaling B over D. In this case, we just switched the means. So we had 2 to 3 is equal to 4 to 6, and we just switched the means so that it becomes 2 to 4 is equal to 3 to 6. Again, the cross products remain the same, 2 times 3, 3 times 4. Finally, we have the last case where A over B equals C over D is equivalent to A plus B over B, and that's equal to C plus D over D. In this case, we add the denominator to the numerator. So if in the first case we have 2 over 3 becomes 2 plus 3 over 3, and then the second one becomes 4 plus 6 over 6. And we'll see that if we find our cross products, again, it really doesn't change it. So let's look at an example of how to apply these properties. So in the diagram, x over 6 is equal to y over 7. What ratio completes the equivalent proportion x over y equals? So if we look at our properties, this is like property number 2. In the sense that before we had x over 6, and we had y over 7, and we've now just switched our means. So now instead of having x over 6, we have x over y, and then instead of having y as a numerator, we now have 6. So x over y is equal to 6 over 7. Another way of thinking about this, another way we could set this up, is to say that 6 plus x over 6 is equal to y plus 7 over 7. This is like example number 3, where we've just and you can see that in the picture, right? The relationship of this whole thing to this part is going to be equal to this whole distance to this part. And so that's why number 3 works as well.